In this lesson, we're going to talk about factoring completely. It's just more of the same, except we add another dimension to it. If you see here at number 1, you look for a greatest common factor and factor that out first. Then, what's left, you look to see if there's only 2 terms. Ask yourself, is that a difference of squares? And if so, that's the way to factor it. And if there's 3 terms, use the box or do mentally to see if you can factor it. Now, if there is a greatest common factor and you can factor it out, your answer is not going to be prime. You may have to leave the quadratic term just as it is, but you'll still show it with the greatest common factor factored out. So let's look at this first example. All right, in this example, you've got 6x cubed plus 3x squared minus 18x. And so the greatest common factor is the first thing you're going to have to identify. And so I'll go over here and we'll write that the GCF of this one, the GCF for this of 6x cubed, 3x squared, and 18x, the numbers, the biggest number, greatest common factor would be 3. And all of them have at least one x, so the greatest common factor is 3x. So what that means is I'm going to divide each of these by 3x, each of these terms, okay? And then when I write it with that factored out, I have 3x times 6x cubed divided by 3x is 2x squared plus just an x and minus 6. All right, then we have to look and see if we can factor this as two linear factors. So we need something that would add to be 1x and multiply to be negative 12x squared. And so our factors in this case are going to be 4x, positive 4x, and negative 3x. That's what that middle term, what's going to take the place of the middle term. Okay, now I need room to work, so I'm going to erase this bit right here. Okay. And I'll work my box. So I'm going to go here to the box. Okay, put that in. And I have, I just work with the quadratic section, so I have 2x squared, and I have minus 6, and then I put 4x and negative 3x on the diagonal. Again, we've been doing this. Since 4 is a multiple of 2, we'll have the 2x here, and the x, the way we're going to get 2x squared. X times negative 3 would give me 3x. 2x times 2 gives me 4x, and then negative 3 times 2 is negative 6. So my factors, this factored, will be x plus 2 and 2x minus 3. So the complete factorization, my answer that you're going to want is, for this one, is 3x. Remember, you have that's there. You factored it out. X plus 2 times 2x minus 3. And that's the whole answer. You have you can't forget to put the greatest common factor in front, because that's part, it takes all that multiplied together to get back to your original expression. All right, looking at this, the greatest common factor, and I'll write it down here, the greatest common factor of 5x cubed minus 5x is 5x. So I'm going to factor out 5x. That means I divide each term by 5x. So 5x cubed divided by 5x is x squared. 5x over 5x is 1. Now, so we factored out our greatest common factor. The next question, step 2, if there's 2 terms, is it a difference of squares? Well, yes, I can take the square root of x squared is x, and the square root of 1 is 1. So this will further factor as 5x times x minus 1, x plus 1. And then that's my final answer. If you can get these down to linear factors, and what I mean by linear factors is factors where the highest power of x is just x to the first, that's as far as you're going to be able to go. You're not going to be able to factor it anymore. But as long as you have a squared term, you need to look to see if you can factor it more. You may or may not be able to. All right, in this one, we have 8r squared minus 4. Our GCF, which we're going to pull out first, is going to be 4. So dividing each of these by 4, we have 4 times 2r squared minus 1. Okay. Now, we could try to factor this. It is 2 terms though. Is it a difference of squares? And the answer to that is no. I can't take the square root of 2 and I can't. So it's not a difference of squares. Since it's not a difference of squares, that's our final answer. Just like that. Okay. All right, let's move on to the next page of notes. Okay, go back to our pen. Again, same strategy. Is there a greatest common factor here? No, there's not. There's not a letter that they all have in common. There's not any factor. This only has 2 and 1, and these are obviously odd. So here we just use the strategy we used before. We need something that will multiply to be 30z squared, and will add to be negative 11z. They're both going to be negative because the sign is positive. Okay. And that would be negative 6 and negative 5. Would add to be negative 11 and multiply to be positive 30. So we're going to go to the box. Okay. Next time I'm going to teach you factor right grouping, but we're going to just go ahead and use the box for this one. 2z squared and 15. And our factors are negative 6z and negative 5z. Okay, so since 6 is a multiple of 2, the 2z is going to go out here and the z up top. Z times negative 5 is 5z. 2z times negative 3 would be negative 6z. So now we have our factors. Y'all, from your quizzes the other day, it shows that you're getting pretty good at this, most of you. Z minus 3 times 2z minus 5. And that are the two factors that if I multiplied them back would give me this polynomial. Example 5, we have, it looks like just greatest common factor of 2n. So I'm going to factor out 2n and see what we have. That's going to give me 4n squared minus 22n squared, n plus 14n. Okay, 14 just 14. And actually it looks like I made a mistake. Our greatest common factor is 4, and I should have seen that. So I'm going to erase this. And we're going to go and start over. Doesn't hurt if you see me make a mistake. We're going to factor out a 4n. So that leaves me with 2n squared minus 11n plus 7. Now, step 2, is it 2 terms or 3 terms? It's 3 terms. So we're going to see if we can factor that. So let's look. We want factors that multiply to be 14n squared and add to be negative 11n. They both have to be negative. Well, 14 can be 1 times 14. 2 times 7. That's about it. Well, can't be 2 times 7. None of those add to be a negative 11. So if this was just this part in parentheses right here, then we would say it was prime. But we can't call this prime here on the left because we were able to factor out a greatest common factor. We just can't go any farther. We have to leave this quadratic unfactored because we can't, that part is not factorable, this 2n squared minus 11n plus 7. But we can factor out a greatest common factor, so I don't write prime. This is what I'm trying to say. This part is prime, but since we could factor that out, we have to write our answer showing the greatest common factor factored out. Okay, looking at this next problem, looks like the greatest common factor is 4 again. And dividing each by 4, we're left with v squared minus 10v plus 9. Factors are both negative, so it looks like it's going to be 9 times 1 is 9, 9 plus 1 is 10. So we'll go in here with our box. And we're just working off the quadratic that's in parentheses, so that's v squared. Looks a little bit like an R, I know, with this. We have 9, and then we said we had 9v and v. All right, so, and they're negative because the 40 is negative. Okay, so v times v is v squared. V times negative 9 is 9v. V times negative 1 is negative v, and negative 9 times 1 is positive 9. So remember, in your answer you have to put the greatest common factor out there, and then you have your two linear factors, v minus 9 times v minus 1. And that's your final answer. That's the way that if I multiplied this back, I would get my original expression. Now this next part is review. The sides of a piece of cardboard in the shape of a right triangle are in the ratio of 5, 12, and 13. Well, let's just draw a right triangle and label it. Okay. 13 has to be the hypotenuse because the hypotenuse is always the longest side. And we have 5 and 12. They're in that ratio, so even if there's multiplied by something, even if there are multiple of this, it's going to be all the same multiple. It could be 10, 24, and 26. Some multiple that adds up, the perimeter is 60. So I have, in other words, I have 13x plus 5x plus 12x is equal to 60. Some multiple of that. So that gives me 1830x equals 60. And so when I divide by 30, x is equal to 2. So what is the shortest side? Well, the shortest side is going to be this one. But to have a perimeter of 60, they're all multiplied by x. So in other words, the shortest side here is going to be 10. And be sure you always put a unit on it, which is given in the problem. So it's 10 feet. All right, we're going to stop the video and we'll have one more for this unit and we'll be ready for a test.